For those listening to the two parts of the recording, I realize there's a slight overlap here, but you can probably handle it. This is the instance I talked about earlier. They will put a dot in there if it is supposed to go through the center, or to make sure you know it's not the center, they'll maybe put a dot just off of there so you know it doesn't go through the center if it ends up being important in the problem. So IJ is a diameter, because that dot in the middle there means it is going through the center. And, well, this is an inscribed angle right here. And notice I did make a triangle there to see if maybe I could distract you from the important stuff. Well, it creates that arc. Do we know how many degrees that arc is? We actually do, because we know IJ is the diameter based on the problem, so we do know that that is 180 degrees, which means that one over there better be 90. So in our job now is to figure out what x value will actually make 4x minus 5 end up being 90. So I'll ask another question, just having to have you thinking about your algebra a little bit more. Could I divide everything by 4 right now? Yes. Is this as good of a choice as the one we had earlier where we divided by 2? Now, I'd say this is a horrible choice to try and divide everything by 4 because you get fractions. But just in looking at these numbers, I don't think this answer is going to come out nice anyways. So 4x equals 95. Pretty sure 4 does not go evenly into 95. Okay, so you divide by 4. 23 3/4? Or 23.75, correct? Does anybody disagree with that answer? I think that's correct. Any questions on that one? No? All right. I like this one because it actually is going to make you think. Your initial reaction is, let's set them equal to each other. But do we know they're equal? If we know they're equal, we can do that. Okay. Do we know that LKNM is a square? Do we know that? Could it be? It could be. We don't know. The problem is a lot of people think that if I connect L to N, that it's guaranteed to be a diameter. Could it be? It very well could be, but do we have any way to know that? No, we don't. So can we just set those two equal to each other? No. That would be the only reason you could, because each would be, equal to 90, but we don't know that. So does anybody have a strategy that might help us solve this then? Okay. Okay, well, let's take a look. Here's what I was told. Why don't we just take a look at them separately and see what happens? Do you agree that that inscribed angle creates that arc? Do we know that arc? Unfortunately, we don't. It'd be great if it was 180, right? But we don't know that. We don't know that for sure. Well, and then what I was told is let's take a look at the other one, kind of like we've been doing. And that creates that arc. Again, do we know what that red arc is? We don't. But that's a good start. At least now we can see the two types of problems. Yeah. No, there is some leeway there. They do not have to be 180. Well, as if I'm understanding your question correct, they do not have to be 180 just because they meet like that. Yes, but we may come back to that because 180 does become part of this problem. So we'll see if I understood your question right. Close. We are going to add the two inscribed angles together. Do you agree that the two arcs put together are 360? And the two angles put together are the ones creating that arc of 360, correct? So let's add those two inscribed angles together. So what is that? 3x minus 4 plus 2x plus 9. I agree. That's the two inscribed. Together they create an arc that's 360. So we are not going to actually set it equal to 360. And this is where that 180 comment may have actually been right, depending on your thought process. Agreed that it's always half the arc that you're creating. I'm creating a 360 degree arc. So I'm not going to set this equal to 360 because these are inscribed. I'm going to set it equal to 180. And so now that depends on what your thought process was as to whether that's what you meant or not. So, yep. So now that's how we're going to take a look at this one. And then it'll help us figure out each one. So let's see, is there any combining I can do on the left side? Yep, 3x and 2x combines to 5x. And how about a -4 and a +9? +5 equals 180. How about dividing by 5 everything right now? That's a possibility. That's actually probably not a horrible idea. But let's subtract 5. Divide by 5. X is 35. Now let's put it this way. Now I could ask you, would segment LN be a diameter? What you would do is substitute the 35 back in and see, does it end up working out properly? So you put 35 back in. What do we get for this angle up here? If you take 3 times 35 and then -4. 101? Is that what it is? Well, if that's 101, is that a diameter? Because for that, what would this angle have to be for LN to be a diameter? 90, very good. Okay. And then if I put 35 down in this bottom one, what do we get there? 79. So did those end up being the 180 they were supposed to? Yeah. Mm-hmm. So was it a square? No. Was LN a diameter? No. Okay. Could you now figure out the red arc and the green arc if I asked you to? No. You just double them and put them out there. And they'll add to 360, guaranteed. Okay. So that one was definitely much more difficult. Any questions?